Let's take a look at this circuit. We're supposed to find again the truth table for this diagram. First, you're supposed to find the number of combinations which you can apply to these three inputs. Remember, the formula says number of combinations is equal to n, where n is the number of inputs, or the variables a, b, c in this case. So this is 2 to the third, which is equal 8. We are going to have 8 different combinations applied to the circuit. Next, I'm supposed to draw my table. I have A, B, C, where A is my least significant bit. I have 8 combinations. 0, 1, 2, 3, 4, 5, 6, 7. Next, I'm supposed to find the output function of my circuit. I have to find the Boolean expression of my circuit. Simply, I'm going to write A naught over here, because A inverter is going to give me A naught. I'm going to have B over here. A naught and B gives me A naught B. C inverted is going to give me C naught. And I have exclusive OR. This is A naught B exclusive OR C naught. This is my Boolean expression for this circuit. Next, I'm supposed to make the columns in this table different than A, B, C. So I have to write A naught, because this is the very first variable which is different from A, B, C. I have A naught. A naught is the complement of A, because A is applied to the inverter. So whatever comes to inverter, on the output you are going to have the complement of it. So if I have 0 at the input, on the output I'm going to have 1. 1 is going to give me 0, 0 is going to give me 1, 1 is going to give me 0, 0 is going to give me 1, 1 is going to give me 0, 0 gives me 1, and 1 gives me 0. This is my column A naught. Next, I have C naught. I'm going to write C naught over here. C naught is the complement of C. So I have 4 zeros and 4 ones. I have to find the complements for zeros, so they are ones. 1, 1, 1, 1. And the complement for ones are zeros. 0, 0, 0, 0. Next, I have A naught B. I have A naught B. This is AND gate. This is AND of A naught and B. This is nothing else, just the algebraic multiplication. So I have 1 times 0 gives me 0. 0 times 0 gives me 0. 1 times 1 gives me 1. 0 times 1 gives me 0. 1 times 0 gives me 0. 0 times 0 gives me 0. 1 times 1 gives me 1. And 0 times 1 gives me 0. This is my column A naught B. And my final answer is A naught B exclusive OR C naught. Remember, anytime we talk about the exclusive OR, we have to keep in mind that anytime both inputs are different, output is going to be high. So I have 0, exclusive OR 1. This is my A not B, exclusive OR with C naught. That's why I have to look at these two columns. So when I have two different conditions at the inputs, output become 1. They are different, 1. They are the same, is 0. Different is 1. The same, 0. The same, 0. Different, 1. The same, 0. This column is called truth table for my circuit. These are the all possible conditions on the output. Okay, so this is the solution to my problem.